Welcome back. Welcome to this new section on Spring Framework. Let's get started with Spring Framework in this section. The goals of the section are to build a loosely coupled app, a Hello World gaming app with modern Spring approach. A keyword in here is loose coupling. What we want to do in this section is to get hands-on with Spring and understand why do you need to use Spring Framework, and understand all the terminology which is typically associated with Spring Framework. One terminology we already talked about is loose coupling. You would want to understand what is tight coupling and loose coupling. You want to understand what is an IOC container. Whenever people talk about Spring, they call it an IOC container, an inversion of control container. What is it all about? What is an application context? What is component scan? What is dependency injection? And what are Spring beans? We also want to understand what is auto wiring. By the end of this section, you'll get hands-on with Spring, you'll build a loosely coupled Hello World gaming app, and you'll understand all the terminology that we are seeing on the screen right now. Are you ready to get started on this amazing journey? Let's get started right away. I'll see you in the next step. Welcome back. Let's get a 10,000 feet overview of this simple gaming app that we'll be building in this specific section. What you want to do is to design a game runner to be able to run a number of games. You would have played Mario, Super Contra, Pac-Man. So you'd want to be able to have a game runner and use that to run these different kinds of games. You would have used a gaming console like this to play the games. You'd have several buttons on them and you would use them to play different games. Let's try and play with a simplified version of this. What we'll do is we'll implement this in multiple iterations. In the first iteration, we would build some hard-coded, tightly coupled code. We would build something called a game runner class, and we will have game classes like Mario, Super Contra, Pac-Man, etc. In the second iteration, what we'll do is we will use interfaces. If you are familiar with Java, interfaces also help us to make our code loosely coupled. What we'll do in iteration 2 is to use interfaces to make our implementation loosely coupled. We'll use the same game runner class. However, we would build a gaming console interface and we would have these three classes implement the gaming console interface. If you don't remember a lot about interfaces, don't worry. I'll make it simple when we go to iteration 2. And in the third iteration is when we would bring Spring Framework into picture. This is what I would call loose coupling level 2. Interfaces is loose coupling level 1 and Spring Framework is loose coupling level 2 for me. What we'll do is to make the Spring Framework manage all our objects. We have the game runner class, we have the gaming console interface, and we have multiple implementations for each of these games, Mario, Super Contra, and Pac-Man. We will have Spring Framework manage all these objects. So this is like the 10,000 feet overview of the journey that we would be doing in the next few steps. If you're not familiar with loose coupling, tight coupling interfaces, that's fine. I just wanted to give you a high-level overview before we deep dive into the hands-on and understand each of these in depth. In the next step, let's get hands-on with the Spring Framework. I've been using Spring Framework for more than 15 years, and I would want to bring all that experience into play to help you understand Spring Framework. I'll see you in the next step. Welcome back. Let's get hands-on with the Spring Framework. What we want to do is we would want to start creating a Spring project. The best way to create a Spring project today is to go to Spring Initializer. Spring Initializer helps you to build very powerful Spring-based projects in a very simple way. All that you need to do is to go to the website start.spring.io, and I would take the defaults. I would choose Maven as the build tool. I will use Java as the language, and you'd see multiple versions in here. What I would recommend you to do is to not use snapshots or anything which has M1, M2, M3. If you look at the options in here, 2.4.4 and 2.3.9 are the ones which do not have snapshot or M3. And the latest among them is 2.4.4. So I would choose 2.4.4. If you see a version which is greater than this, if you see 2.5 something or 2.6 something or 2.7 something, do not hesitate to go ahead and choose that. And after that, what I would do is I would go and give a name to our project. The way we can give a name to our project is by giving it a group ID. This is like a package name. I'll call this com.in28minutes. the project is to learn Spring Framework. I'll take the defaults for all the other things and I would click generate. This would generate a project for us. If you go to your downloads folder, you should see a zip with the name learnspringframework.zip. What I would recommend you to do is to extract that zip folder and copy it to some folder on your local machine. Now I've launched up a new Eclipse with a new workspace. And over here, what we want to do is to import the project that we created earlier. How do we do that? File, import, type in existing and Maven. So type in existing Maven and you'll be able to pick this up, existing Maven projects, and you can click next. And over here, you can choose the folder where you extracted the zip file to. So I chose the folder where I extracted the zip file to, and you should see a pom.xml that is listed in here. Do not worry about what pom.xml is, what Maven is. We'll talk about it a little later. For now, the important thing is I can go in here and click finish. And when you click finish, you would see a lot of magic unfold. In the background, you can see that there is a lot of imports that are in progress. So our project is now getting configured. I'll wait a little while for all the downloads to complete. Typically, it would take between 2 to 3 minutes the first time you set up a Spring project. So you can wait for everything to download. And once the downloads complete, you should see a folder structure like this. What you're seeing in here is a typical folder structure for any Java project. Source main Java is where your source code is present. And inside that, you should see a file called learn spring framework application.java. If you open this file and if you run as Java application, if you do just a run as Java application, you'd see that after a little while in the console, you should be able to see some output. Spring Initializer makes it very, very easy to create Spring-based projects. And that's what we did in this specific step. We created a project, we imported it into Eclipse, and we were able to run it. However, there are a lot more things that we would want to understand about this project. What's happening in the background of this particular project. That's what we would be doing in the subsequent steps. I'll see you in the next step. Welcome back. It's time for iteration 1. What we want to do is to build a game runner class and create a few game classes and run them using game runner. In this step, let's focus on building game runner class and the Mario class. We want to create a Mario game and we want to run it using game runner. Let's see how we would do that in a typical Java way. So what we want to do in here, I'll open up the learn spring framework application.java. That's the only file which you should see in here. And over here, I don't want to worry about this code right now. So I'll comment this out. And what I would want to do is build my own code. So what we want to do is write some Java code. We want to create a game runner class. How do we create a game runner class? Game runner is equal to new game runner, right? So that's how we would typically create our class. The class does not exist. We'll create that very soon, but this is how we would create our game runner class. And once we have the game runner class, what we want to do is we would want to run the Mario game. And to be able to run the Mario game, I would want to actually, let's say Mario game is equal to new Mario game. And after that, what I would want to do is to do runner.run. We create a game and we would want to run the game. How can we pass the game to the game runner? The way we can do that is by passing in game as an argument to game runner. So what I'll do is actually move line 12 down and put it in here. So we are creating a game. We are creating a game runner with that game, and we would want to be able to run this. Looks simple. Let's now create these games. So Mario game, I'll go here and press Ctrl 1 or Command 1. I'll go here and press Ctrl 1 or Command 1, and I'll say create class Mario game. And I would want to put it in a package, learn Spring Framework. And because we would be playing with the game, let's create a game package. So com in 28 minutes, learn Spring Framework .game is where we would be creating everything. So make sure that you are creating it in a sub package of the package which is already existing. And let's press finish. So we have the Mario game present. And what we want to do is now create the game runner class as well. Control 1, and I would say create class game runner. And I would want to put this as well into the game package that we created earlier. So that looks cool. So let's select this. And let's say finish. So the game runner class is now there. I'll go back to the Learn Spring Framework application class. Still there is a compilation error because the constructor does not exist. So what we would do is in the game runner class, we would create an instance. So Mario game, and I'll call this game. And let's make this private. And over here, game runner, I want to create a constructor for game runner. So Control 1, game runner, and this would create the constructor for us. So I'll rename this to game. And what I'll do is remove this line. I'll move private Mario game up. All the member variables would be the ones which would be at the top. After that, we have the constructor. And in the constructor, what do you want to do? This dot game is equal to game. So what we have now done is we have created a game runner, and inside the game runner, we would be able to run the game. What is the game that you would want to run? Mario game. And typically, whenever you're playing a game, you have a number of buttons which are present in here. What we'll do is we'll choose 4 of these buttons: up, down, left, and right. Typically, there would be 8 or more buttons. What we'll do for now is just choose 4 of these, and let's play with 4 of those buttons alone. So let's say in the Mario game, when up button is pressed, you want to do something. When down button is pressed, you want to do something. So let's create a few methods for that. So public void up. When the up button is pressed, let's just do a sysout. Just a sysout up. And let's create similar methods for. So there is a little bit of setup that is needed so that we would be able to understand the Spring framework better. So up, down, left, right. So let's quickly set this up. Left, right, up, down. So that's cool. So we have now a game ready to be played. And in the game runner, what we want to do is we would want to play the game. What we would do is to play the game, we'll create a method in here. So let's call this public run game. And let's say in the run game method, let's do a few actions. So while you're playing the game, you would do game.up. So you'd press the up button, maybe you'd press the down button. You'd be sometimes pressing the left, right buttons. So let's make the calls to that in here. So we have a public, let's make it void. So public void run game, game.up, game.down, game.left, and game.right. So what we are setting up in here is a very, very simple thing. So we created a Mario game and we would want to run it, and to be able to run it. So in the game, we created a game runner, and earlier we called it run. Let's call this run game. So runner.run game. That's the method that we have defined in here. And now everything is set. So let's go ahead and run this, run as Java application. Cool. Up, down, left, and right. So we have created a Mario game and we use the runner to run it. And we were able to click a few buttons and cause a few actions to be done. In the Mario game, when up is clicked, maybe this would be a jump, right? And when down is clicked, maybe it's about going into a hole. When left is clicked, maybe it's stop. And when right is clicked, probably it's all about go faster, accelerate, right? So now if I have something like that, I would be able to come here and say run as Java application. What we are doing in here is simple Java. There is nothing Spring to this. The reason why we created this example is to understand the concept of tight coupling. Why is this tightly coupled? to understand that, let's create another game. So what I would do is I would actually take the Mario game class and I'll say Control C, Control V. I would save the existing resources. I'll say OK. And I would call this, let's call this the Super Contra game. So not just the Contra game, we want to create a Super Contra game. And let's say in the Super Contra game, what we want to do is system.out.println up. Let's just go back to what we were having earlier. So left, and let's say right is all about right. So the implementer of the Super Contra game provided this implementation for the different methods. Now, let's say I would want to switch the game runner to use this Super Contra game. Instead of the Mario game, we would want to be able to use the Super Contra game. Let's see what is involved in doing that. So I have to go Mario game is equal to, I'll comment this Mario game, and let's actually, instead of Mario game, let's try and use Super Mario. Instead of Mario, let's use Super Contra. So Super Contra game is equal to new Super Contra game. Will it work? It's giving me a compilation error. Let's fix that by organizing imports. So everything is organized. We have all the imports in here. But you can see that the game runner class is giving you an error. If you open the game runner class, the game runner class is expecting Mario game as the input. The game runner class cannot work with different kinds of games. The game runner class is now tightly coupled to Mario game. If I would want to actually run the Super Contra game, one of the options that I have to do in here is I can take the Super Contra game and make the game runner class, use the, instead of the Mario game, I can say Super Contra game, and organize imports and save this and come here, and then the code would compile. But to be able to run the game, we needed to make a change to the game runner class. Earlier, the game runner class was tightly coupled to the Mario game, and now game runner is tightly coupled to the Super Contra game. How can we make this loosely coupled? As you can see in here, tight coupling and loose coupling is all about how many changes do you need to make. Whenever I would want to switch from Super Contra game to the Mario game, I would need to make a lot of changes to the game runner class. So the game runner class is tightly coupled with this. How can we make it loosely coupled? That's what we would be doing in the next step. In this step, we completed the iteration 1, where we built a tightly coupled game runner class, which is tightly coupled to Mario and Super Contra classes. Let's go to iteration 2 and make this loosely coupled in the next step. I'll see you in the next step. Welcome back. Let's now bring in the magic of interfaces and implement loose coupling level 1. How do we make this loosely coupled? What we will try and do is to create a gaming console interface. How can you create an interface? Let's do that right now. What I can do over here is right click, refactor, extract interface. I can go in and manually create the interface as well, but what I wanted to show you is an automated way of creating an interface. Extract interface, and now you'd see some magic go on. It's asking you for an interface name, and the interface name I would want to give it is gaming console. The gaming console has these buttons, right? Gaming console has the up, left, right, and down buttons. And I would want to include all these into the interface. And let's go ahead and say OK. You can see that a interface is automatically created. So interface is now created, gaming interface, gaming console, void up, down, left, and right. And you can see that the Mario game is implementing the gaming console. And what we can do is we can even make the Super Contra game implement the same interface. What the interface is representing in here are the actions that you can do. I can do up, down, left, and right. This is representing the gaming console that you have in here. It represents all the actions that you can do by using the different buttons which are present in the gaming console. And over here, what we are now doing is we are making the games, Mario game, implement the gaming console, as well as the Super Contra game to implement the gaming console. Now, you might be wondering, what is the advantage of doing this? See the magic now. I can go to the game runner class, and instead of having the Super Contra game or the Mario game in here, I can make use of the interface. I can say gaming console. So in the game runner class, we are now switching it to use the gaming console. Whichever implementation you provide in here, the game runner can make use of that. Whether you're creating a Mario game or a Super Contra game or a Pac-Man game, the game runner can run it. That's the magic of interfaces. And now you can see that if I go to the application class, I'll be able to run Super Contra game without making any changes. So right click, run as Java application. Up, down, left, and right. That's cool. Let's comment this out and let's uncomment the Mario game. And let's organize imports. And let's right click, run as Java application. Will there be any magic? You can see that we are now able to run Mario game. What we are doing in here is loose coupling level 1. What we are doing is we are able to switch from Mario game to Super Contra game without making changes to your game runner. In this step, what we did is we implemented loose coupling using interfaces. When we used an interface called gaming console, we saw that to switch from Mario to Super Contra game, all that we needed to do is do a simple code change in the Learn Spring Framework application class. We did not need to make any changes in the game runner class. So game runner class is loosely coupled to whichever game it's running. That's because we are using an interface. I'm sure you're having a wonderful time, and I'm all excited to start introducing the Spring Framework to you and go to level 2 of loose coupling. I'll see you in the next step. Welcome back. In the last step, we got to level 1 of loose coupling. How do we get to level 2? Before that, let's try and understand the problem that we are trying to solve. One of the things that you are seeing in here is the creation of the Mario game, the creation of the Super Contra game, and then the creation of the game runner is all done through Java code. Typically, whenever you are talking about enterprise applications have thousands of classes. Instead of manually creating objects, can we delegate the creation of objects to Spring Framework? Can we have the Spring Framework manage the creation and the life cycle of the objects that we are creating in here? Now, all that theory might sound a little complex. Let's get hands-on. What we want to do is to make this Spring Framework to create the Mario game, and we would want to create a game runner class with the Mario game as a constructor argument, and then we would want to call run game. Let's see how we can ask the Spring Framework to do that in this specific step. So I'll go to the Mario game, and I would just put something called add component in here. So what we are doing in here is add component, Control-Shift-O or organize imports. And you'd see that there's an import org Spring Framework stereotype component which is imported in. So we are saying that Spring Framework, you need to manage this component. This annotation, what we are saying in here is Spring Framework, you need to manage the Mario game. And what I would do is I would go to the game runner class as well. And what I'm going to do in here is go in here and tell the Spring Framework, hey, I would want this class to be managed by you as well. So you go ahead and create an instance for this for me. So what we are doing is going to the Mario game and the game runner, because these are the two things that we want to start with first, and we added add component in them. So the Spring Framework would now say, hey, I can see add component in here. I would create an instance of the Mario game. And it says, and it can say, hey, I can create a game runner for you, but game runner needs something. Game runner needs a game to run. How can I find it? And you can say, hey, I've already indicated that the Mario game is a component. So you can go and find it. And then once you find it in your list of objects, you can auto wire it in. And how can I say that? The way I can say that is by saying at auto wired, and I'll do a organize imports. So add component, add auto wired. And on the Mario game, we have add component. Now over here, what I can do is I can uncomment the code that we created earlier. Spring Framework needs to manage these components. So it needs to create a component for Mario game, it needs to create a component for Game Runner, and auto-wire the Mario game into the Game Runner. So Spring Framework needs to manage the life cycle of these components it creates. And in Spring Framework, there is a name which is given to that. So if you look at this right now, when I uncomment the code, I can see a compilation error. If you do an organize imports, you would see that org Spring Framework boot Spring application would be imported in. That's cool. Now, if you go in here and do a control 1 or command 1, you can say assign statement to new local variable. And you can see that an application context is being created in here. I'll choose context as the variable name. And I'll put this to the next line so that you can see the entire code clearly. So what we are doing in here is we are creating an application context. We are creating a number of components and we need something to manage these components that we are creating. And how do we do that? The way we do that is by creating an application context. In the application context, there'll be multiple components that we are requesting to create. We are requesting Spring to create a Mario game component. We are requesting Spring to create a Game Runner component. And we would want to pick the appropriate component from the context. How can you pick the appropriate component from the context? The way you can do that is by saying context.getBean. So over here, context.getBean. The method is getBean. And what we want to do is we would want to get the bean for Game Runner class. So I would say Game Runner dot class. So what we are saying is Spring Framework, you create a context, and when Spring Framework launches a context, it would see that we have a component here, and it would see that we have a net component here. So it would create objects for these two. And what we are saying is we would want to get the object of the Game Runner class. And what do we want to do with this? What we want to do is assign it to a new local variable. So if I do a command 1 or control 1, I can assign it to a new local variable. And this would create the runner for us. And I can say Game Runner is equal to context.getBean Game Runner.class. And now I can go ahead and comment the earlier manual creation of Mario game. So I don't need to manually create the Mario game anymore and the Game Runner class anymore. And I can directly run the game. I don't need to worry about the creation and the wiring of objects. Spring Framework does that for me, and I can pick up the right object and I can use it to run my business logic. And I can say right click, run as Java application. What would happen? If everything works fine, you should see that the application would run as usual. Congratulations on getting your first Spring example running. Now, you might be celebrating about the fact that we got one example with Spring Framework running, but there might be a number of questions like this at the back of your mind. What is happening in the background? I just added in a component on Mario game and on the Game Runner, and I just added in at AutoWire, and I was able to see that Spring Framework is automatically creating objects for them. What's happening in the background? How does the Spring Framework do that? What we'll do is we'll try and debug and figure that out. The next question that you would also have is, what about the terminology? How does it really relate to what we are doing in here? Whenever we talk about Spring Framework, we would talk about dependency injection, IOC container, application context, component scan, Spring Beans, auto wiring, etc. A lot of terminology that is associated with the Spring Framework. How is it related to what we are doing in here? Another question you might be wondering about is, does the Spring Framework really add value? We are replacing 3 simple lines with 3 complex lines. If you go to the Learn Spring Framework application, you'd see that earlier we had 3 simple lines. However, right now we have a little bit more complex code. Does Spring Framework really make applications simple, or does it make them complex? The fourth question you might be having is, what if you'd want to run Super Contra game? Right now we are running Mario game. If I look at the console, it's showing the output from the Mario game. What if you would want to run Super Contra game? And the last But one of the important questions is, how is this Spring Framework jar downloaded? If you go and see in here, in your project, on the left-hand side, there is something called Maven dependencies which is present. You'd see a lot of jars in here. How are these jars coming in here? Who downloaded the jar for us? And how did the jar become available to our application? What we'll do in the next few steps is try and understand each one of these. Congratulations on getting your first Spring Framework application up and running. A few years back, getting a simple Spring Framework application running would take more than an hour. With the evolution in the Spring Framework, you can see that right now, to launch up a very simple application with Spring Framework, you can do that in a few minutes. Let's try and understand this further in the next few steps. Welcome back. In this step, let's focus on the first question. What's happening in the background with Spring Framework? If you look at the log right now, when you run the application, you'd see a little bit of log which is printed. There are just 3 lines of log which is printed at something called an info level. I would want a lot more log to be printed. To get a lot more log to be printed, what we'll do is we will enable logging at a debug mode. When you enable debug mode, a lot of log would be printed, and that allows us to see what's happening in the background. So what I would do in here is go to source main resources, and in here you'd see a file called application.properties. In the application.properties, you can configure your application. What we are configuring in here is the logging level. How do we set the logging level? The way you can do that is by saying logging.level dot which packages. If you look at the Spring Framework classes, they would all start with org.springframework. Let's pick up one of these. You can see that all Spring Framework classes start with org.springframework. And that's the reason why what you want to do is for all the org.springframework. So you can see that in here it's level logging level dot org.springframework is equal to, I would want to set it to debug. Let's save this and let's rerun our application. Let's see what would happen. You can see that a lot more log is being printed, and this would allow us to see what's happening in the background. There is a lot of log that is printed, and to make things easy, what I've picked up is the important messages and made them available in the presentation. One of the important things to remember is that these logs keep changing. Spring Framework keeps changing the log which is being printed. The best way to look at the log is to search for something like Game Runner. Take Game Runner and you can search through the log. You'd see that this log keeps changing with different versions of Spring Framework. But essentially, if you have everything working fine, you don't really need to worry about the log. Let's try and understand what's happening in here right now. So you'd see in the log that Spring Framework has identified a candidate component class, GameRunner.class, and also MarioGame.class. How does this happen? This is happening because we have add component. So in each of these classes, in the Game Runner class, I have add component. In the Mario Game class, also I have add component. And therefore, Spring identifies them as candidate component classes. So these are component classes. Once you have the component class, Spring would try to create an instance of that specific class. In Spring's terminology, by default, it would create something called a singleton bean. It would create one instance of this class. You can see that the name of the instance it's trying to create is very similar to the name of the class. Only the first letter is made into small case. So it's Game Runner with a small g. So it's trying to create a shared instance of this bean. And after that, it's trying to create an instance of the Mario game. And after that, you'd see some log saying auto-wiring by type from bean name Game Runner via constructor to the bean name Mario game. What's happening in here? Spring identified Mario game and Game Runner as component classes. And now it wants to create instances of these. However, if it needs to create an instance of the Game Runner, Spring Framework sees that there is an @AutoWired in here. We have a constructor and we have an @AutoWired. What Spring Framework realizes is that it needs a instance of a implementation of gaming console like Mario game. So it creates the instance of Mario game and it auto-wires it using this constructor. So it would call this constructor and auto-wire the Mario game into the application. If you want to be really sure, you can also do a system. You can also do a sysout. So system.out.println, and I would say using constructor. And if I run this again and search for using constructor, you'd see that using constructor would be printed in here. So while auto wiring, what are we using? We are using the constructor. The idea behind this step is to help you understand what's happening in the background. Let's play further with the Spring Framework in the next step. Welcome back. Let's now look at the important terminology that is associated with Spring Framework. We used @component to indicate that a class has to be managed by Spring Framework. A component is nothing but a class which is managed by the Spring Framework. The next important terminology is dependency. If you look at the game runner, it needs a implementation of the gaming console interface. How did we specify that dependency? The way we specified that dependency is @AutoWired. So we are saying in here, game runner needs gaming console, and we created a constructor for it. Implementation of a gaming console, for example, Mario game, is a dependency for the game runner class. What we mean by a dependency is something a class needs so that it can do its functionality. The game runner needs to be able to run a game. So gaming console or implementation of a gaming console is a dependency of game runner class. The next important concept is component scan. How does Spring Framework find component classes? Where did we define our component classes? We defined them in the package com in 28 minutes learn spring framework.game. The other component class which we created is Mario game, which is com in 28 minutes learn spring framework.game. If you look at them, these two packages are sub packages of com.in28minutes.learn spring framework. And this is where our learn spring framework application class is present. If you look at this specific class, there is an annotation called @springboot application in here. And if you control click this, you'd see that there is something called component scan, which is defined as part of your Spring Boot application. So what's happening in the background is as soon as we are launching a Spring context in here, a component scan is done. Which packages is the component scan done on? By default, a component scan is done on the same package where your @springboot application annotation is present. So by default, if you look at it, it's almost like this: @component scan, and I would want to do a component scan on this particular package. So this is the default. If I do organize imports, this is the default. If you'd see that if I add a component scan in here and do a run as Java application, you'd see that nothing would change. The application would continue to work as it is. However, if you go in and let's change this, I'm saying learn Spring Framework 1. This is not an existing package. You'd see that there would be a failure. Run as Java application. And you'd see that there is an exception. It says no such bean definition found. It's saying I'm unable to find game runner bean. If you click the line in here, Spring Framework application.java, 20th line. If I click this, it would take me to the line which causes the problem. So what we are doing in here is we are saying Spring Framework launch up. Once Spring Framework has launched up, what we are saying is I would want to get game runner bean. But the exception says that there is no bean for the game runner class. Why is there no bean for the game runner class? Because Spring Framework is looking at a wrong package. It's looking at com in 28 minutes learn Spring Framework 1 for components. However, the components are not defined in that specific package. The components are defined in COM in 28 minutes learn Spring framework. And that's the reason why this should be how your component scan should be. Since this is the default package which is component scan, I don't really need to specify this. I can comment this as well. So component scan is how Spring identifies the component classes. What Spring does is it goes and searches this package. It searches all the classes in this package and sees if any of them have a add component annotation on them. There are a few other annotations Spring Framework looks for as well, but the most important one is add component. Once Spring is able to find add component classes, it would try and create instances for them. So Spring does component scan by scanning the packages. The next important terminology is dependency injection. Whatever we are seeing the Spring Framework do in this specific example is what is called dependency injection. It does a component scan. It identifies component classes. It creates instances for them. It identifies the dependencies that are present for each of these classes. It creates instances for those dependencies, and it would wire the dependencies into the beans. This entire process, what Spring Framework does is called dependency injection. This is also called IOC, or inversion of control. Why is it called inversion of control? Earlier, as a programmer, you were responsible for creating all the classes. You are responsible for creating the Mario game. You are responsible for creating the Super Contra game. And you are responsible for wiring the Mario game into a game runner class. However, right now, we gave that responsibility to Spring Framework. So instead of the programmer having the control of creating objects and wiring them together is now with the Spring Framework. And that's the reason why this is called inversion of control. There are a few more terminology which you need to remember. One is Spring Beans. A Spring Bean is nothing but an object managed by the Spring Framework. When Spring Framework finds component classes, it goes and creates instances for them. Spring Framework creates an instance of the Mario game. Spring Framework creates an instance of the game runner. These instances are also called Spring Beans. These are beans or objects which are managed by the Spring Framework. The creation of the object, the life cycle, and the destruction of the object, everything is automatically done by the Spring Framework, and that's why these are called Spring Beans. The next important terminology that you would often hear is IOC container. We talked about IOC as inversion of control. What is IOC container? The technical component inside this Spring Framework which implements the dependency injection logic is what is called the IOC container. So dependency injection is a concept, and the dependency injection feature in Spring Framework is provided by a IOC container which is present in Spring Framework. The popular types of IOC containers are application context and bean factory. I have built more than 20 Spring Enterprise projects, but I have not used bean factory even once. All of the projects I have built use application context. It's a little bit more complex than the bean factory, but that is the one which is most frequently used. And that is what we are using in here as well. So we are using application context. What we are doing is Spring application.run, and the Spring application.run would create an application context for us. And from the application context is where we are picking up our beans. One of the important responsibilities of IOC container is auto wiring. Basically, it's all about identifying the dependencies and wiring or injecting the dependencies into the bean. As you can see in here, while the job which is done by the Spring Framework is very, very simple, we make it really, really complex through a lot of terminology. One of the most important challenges that beginners to Spring Framework face is understanding the different terminology. And that's the reason why we designed this question answer kind of an approach so that you can understand each of these terminology in depth. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. After understanding the terminology, let's try and figure out another important question. Does the Spring Framework really add value? We have 3 lines of code earlier, and now we have little bit more complex code. does this really add value? In the Game Runner Hello World app, this is kind of a Hello World app, right? So very, very simple app. We have very few classes. But when you talk about real world enterprise applications, these are much complex. There are multiple layers. You have a web layer, a business layer, a data layer. I have worked with enterprise applications with 100,000 classes. That's how big enterprise applications can be. And you don't want all the 100,000 classes together. And that's the reason why we divide them into layers. You have a web layer, which is responsible for the UI logic. You have a business layer, which is responsible for the business logic. You have a data layer, which talks to the database. So whenever you talk about an enterprise application, you have multiple layers, and each of these layers is dependent on the layer which is beneath it. The web layer is dependent on the business layer. Business layer is dependent on the data layer. Data layer gets the data from the database. So most classes in each of these layers talk to another class in the layer below it. A class in a business layer would be talking to a class in the data layer. When a class in the business layer talks to a class in the data layer, then the class in the data layer is a dependency of the class in the business layer. Whenever we talk about even the simplest of the enterprise applications, we are talking about thousands of such classes with thousands of such dependencies. When you're using the Spring framework, instead of focusing on creating objects, wiring dependencies, what you can focus on is the business logic of your application. And you can leave it to the Spring framework to manage the life cycle of the objects. All that you need to do is to mark your components using annotations like add component, and mark your dependencies using add AutoAdd. And you can allow the Spring framework to do its magic. Now, to help you understand the complexity which is typically present in enterprise applications, let's build a simple use case. What we'll do is we'll create a simple flow going from web layer to business layer to the data layer. And we can see how Spring would auto-add them in. In this step, we talked about the fact that enterprise applications are really complex. They have multiple layers and they have thousands of classes with thousands of dependencies. And that's where the real value of Spring framework is in. Let's see an example of this in action in the next step. Welcome back. What we want to do is to build a simple flow. I want to build a simple flow involving a controller, a business service, and a data service. Business service and data service are example classes in the business layer and the data layer. The controller class typically would be present in the web layer. What we want to do is to build a simple web app. How do we do that? The first thing that we need to do is to open up something called pom.xml. We'll talk about pom.xml and how it downloads all the dependencies for us in question 5 when we talk about Maven. For now, the thing which you need to do is to copy the dependency. So you have 4 lines in here where we are defining a Maven dependency. And a Maven dependency is identified by a group ID and an artifact ID. Group ID is like the package, artifact ID is the class. So if you want to download a jar, you need to tell Maven its group ID and the artifact ID. What we'll do is we'll add another dependency in here. The dependencies which we are talking about in here are jars. These are Maven dependencies. I've copy pasted Spring Boot Starter again, and I add in web. We'd want to build a web application. And when you'd want to build a web application, you'd want to add a starter called Spring Boot Starter Web. I'll save this in. Once you save this in, you'd see that a number of jars are downloaded. And now I can go in here and build my flow. I want to create a controller, business service, and a data service. What I would do is I'll say Control N to create a new class. And I would want to create this in a package. Com in 28 minutes learn Spring Framework, sample enterprise flow. So the package I'm putting in here is sample enterprise flow. And I would want to create a class called a controller. And I would click finish. What we want to do is we would want to create a couple more classes. Let's try and get a high level idea first before we go ahead and implement that. So what I would want to do is to create a class called business service. Typically, whenever we talk about enterprise applications, you have multiple layers. So this is the web layer. Controller would be in the web layer, which is responsible for the UI, or if you are building an API, it's responsible for giving the response in the right format. The business service is where your business logic would be present. And you will also have data services. The data services are in the data layer, and these get the data. So data layers are responsible for getting data from the database. This is responsible for business logic, and this is responsible for sending the response to the user. If you have a user who's using the web application, you need to send the response back to them in the right format. For example, if they're expecting response in JSON format or XML format, or if they're expecting response in HTML format, you need to send the response in the right format. So this is the way your enterprise applications would typically be organized. Let's start with hard coding things in the web layer. Let's start with hard coding a few responses back in the controller itself. We would want to build a simple web app, and we would want to return the data back as is. And that's the reason why we can add a controller called REST controller. So I'll add a at REST controller. You can do an organize import, and it would import a at REST controller in. And what we want to do is when user types in a URL, /sum, we would want to, for now, return a hard-coded value back. Let's return the sum back as 100. The way we can do that is by adding a get mapping. So we are saying when user tries to get /sum, what we want to do is to implement a method. Public, the return value is a long value, and I would say display sum. Your web layer or the UI layer is responsible for the display logic. And over here, let's just do a return 100. This is hard-coded value. A little later, we would implement the entire chain. Controller talks to business service talks to the data service. Let's organize imports, Control-Shift-O. You'd see that there is an import org Spring Framework web bind annotation on get mapping. Because we would want to allow user to type in a URL and show him some data. This is typically what is done by a web application or a REST API. And that's the reason why we added in at REST controller. At get mapping allows you to define what is the URL. What we'll do now is to terminate everything, make sure that you don't have anything in the console, and you can start the Learn Spring Framework application again. What we are doing in here is launching up a web application. One of the things that you would see is when we launch up a web application, the server continues to run. The reason why it's continuing to run is because earlier we added in Spring Boot Starter Web. We would want to run a web application. When we run a web application, the web application continues running all the time. And now I can go and send requests to my web application. How can I send requests to my web application? I can go in and type in a URL. The URL is localhost :8080. 8080 is the default port which is used by Spring Framework. How do you find that out? If you search for 8080, you can see that Tomcat is initialized with ports 8080. This is where your application is running. So localhost :8080 / what is the URL which we gave? We gave the URL as /sum. Localhost :8080 / sum. And what would you see? You're seeing the response coming back. So we are able to display the data to the user from the web layer. However, what do we want to do is we would want to integrate all the layers together: web layer, business layer, and data layer. Let's see how to do that in the next step. In this step, we got started with building a simple enterprise flow. I'll see you in the next step. Welcome back. In this step, let's continue developing our flow. So what we'll do now, What we'll do now is we'll bring the business layer also into picture. The business layer is responsible for the business logic. Let's say we want to do a calculation of this sum. So I'll get some data and I want to calculate the sum of it. So I'll name the method as public void calculate sum, and I would return a hard-coded value. Typically, the business service needs to talk to the data service. We'll implement that a little later. For now, let's return 150 from here. So we are hard-coding the return value from here. It should be public long calculate sum. And now I would want the controller class to use the business service. How can I do that? If you know the Spring framework well, then you should say I would make business service a component. Let's organize imports. So the business service is now managed by Spring framework because we have @REST controller annotation. The controller is automatically managed by Spring framework. @controller is a specialized version of @component. So that's not a problem. The only thing that we would need to add in is now I would want to add in business service in here. So I would want to use the business service and get the data using the business service. So business service, let's make it private. Now I would want to make the business service available to your controller. How can I do that? Yep, you are right. You need to auto-wire it in. So let's do an @autowired to auto-wire the business service in. And over here, instead of hard coding this, now I can say return business service dot calculate sum. You can save this out. What we are doing in here is we are making the web layer talk to the business layer. We have a controller talking to the business service. Let's see if this is working. What you need to do now is go to console and stop the running web application. I'll terminate this and I'll launch a new application again. So we made a change, so we need to stop and start the server. And now you can go in and run the URL. Localhost 8080 sum. What do you see? You see that 150 is returned back. So we have the controller auto-wired with the business service, and Spring is managing instances of all these right now. Let's bring the data service also in. So let's say the data service returns the data back. So public data, public. Let's return a list of integer back as data. So I'll call this retrieve data back. And let's say this is returning back, return. Let's create a simple list. I can either use arrays.asList. If you're using Java version 8 or below, then arrays.asList. If you are using Java version 9 or 10 or anything above 9, you can use list.off as well. I'll return some data back. 12, 34, 56, 78, 90. Let's organize imports. Make sure that you import Java util list. We would want to make use of Java util list, and you should be fine. Now we would want to make the business service use the data that is coming back from the data service. How do we do that? I'll say private data service, data service, and can I return the data service dot data back as is, data service dot retrieve data? No, we would want to add business logic on top of it, right? So what I would do is remove the return, and what I would do is I would create an instance in here. So control1 or command1, assign statement to new local variable. I'll call this data. So I have the data coming back. I would want to calculate the sum and return that back. You can use the old approach before functional programming. You can loop around the data and create a sum variable, add them up and return it back. What I would do now is use the functional approach. So I'll say return data dot stream. So I'm converting the data, the list into a stream, and now I can add everything up. How do I add everything up? I can say reduce, and I would say integer : sum. we would want to use the integer sum method to reduce everything into one value. So everything is reduced to one value by using sum. So all of these are added up and reduced to one value, and we would want to return that value back. So I would say dot get and put a semicolon. So what we are doing in here is implementing the business logic. Now we would want to create a instance of the data service and auto wire it into the business service. So I would want to have an at. So I would want to have an at component on the data service. And what should be in here? Think about this. It should be at auto wire. Let's save this. And let's go in, stop the application, start it again, and let's run the URL again. You are seeing 270 now as the response. Why? Because we now have all these components talking to each other. The REST controller is talking to the business service is talking to the data service. So the data which is returned from the data layer is added up by the business layer and displayed out to the user by the web layer. Typically, when you are in the real world, the way these would be is each of these would be in its own classes. I can say .web. So this is the web layer, control1 or command1, and I can say move controller.java to the package which is present in there. So it would actually now move our new class into a package.web. So you can, if I expand this further, you can see enterprise.flow.web. We can also create other packages for classes belonging to different layers. What I'm showing in here is kind of magic where you can easily create classes. When you start off, you can create everything together. And once you are comfortable with them, you can move them into separate classes. The way you can do that is I can come in here, and right above app component is where we would actually have the package. I would want to put this in business package to indicate this is business layer. And I would want to put the data service where? Where do we want to put the data service? I would want to put it in the data package. Now, there are a lot of errors which would come up. That's fine. What I would do is I would cut and I would go in here and I would paste. You'd see that an package is automatically created. So a business package is automatically created and the business service is automatically created. What I would do is very similar thing on the data class as well. So the data service, I would do a cut and I would paste it into source main Java. This would create the data service class. And now I can go to source main Java and do an organize imports. It would say there's a problem. I would say continue. And now I would go into each of these services. So I'll go to the data service and do an organize import. I would import in Java util list. I would go to business service and I would import in Java util list again and save it. Let's do an organize imports again. You'd see that you are not able to use the data service. You'd see that there are a few compilation errors still. The reason is because these classes should be public. So public class business service and make the data service class as well as public. And you can go ahead and do an organize imports again. And you'd see that all the compilation errors would disappear. So when we are in a real world project, we would be having layers like this. You have a web layer, a business layer, a data layer, classes in them talking to each other. And with Spring Framework, all that you need to do is to add the right annotations. Add component. In business service, you would add component on the business service and it needs the data service. So you would have the data service auto-wired in, and the controller also, you do it the same way. You'd see that the entire flow is very clear in here. If I go in here and say package representation is hierarchical, then you can go in here, source main Java, and see the hierarchy which we have right now. So we have a sample enterprise flow where we have business layer, data layer, and web layer. when we talk about typical enterprise applications, there would be hundreds of classes in business layer, data layer, and web layer. And instead of manually creating and auto-wiring them in, you can see that we can easily do that in automated way using the Spring framework. We would leave it to the Spring framework to manage the objects and dependencies, and the enterprise applications don't really need to worry about managing all this stuff. If I stop the application and run it again, you'd see that the application would start up fine. And if I refresh the URL, you'd see that I would get the same data back. Now, what we have set up in here is something really complex. This is little complex for beginners, and you might face a few problems with this. So what I would do is in the previous step, in the step previous to this, I'll make the classes available to you. So the entire code as it is in here, I'll make it available to you so that if you are facing any problems, you can compare your code with whatever code we have in there and make sure that you are able to solve the problems that you have. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, let's shift our attention back to question 4. What if I want to run Super Contra game? Until now, we are using Spring Framework to create instances of Game Runner and Mario and auto-wire the Mario game into Game Runner. What if I would want to run the Super Contra game? What I would recommend you do is to try to pause the video in here and try and see what you can do about it. I hope you got a chance to try that exercise. The way you do that is very simple. I can go to the Super Contra game and I can say, this is a component. I want Spring Framework to manage this. I'll do an organize inputs. What would happen if I stop and start the application again? What would the output that would be printed? Error. It says application failed to start. And it says parameter 0 of constructor required a single bean, but 2 were found. You can see that there are 2 components which are present, Mario game and Super Contra game. So we have 2 implementations of gaming console, Mario and Super Contra, which are available. And when Spring Framework is trying to auto-wire Game Runner, it is not able to decide whether it needs to use Mario or Super Contra. You need to tell the Spring Framework which one you want to use. How do you do that? The way you can do that is through another simple annotation. I can say Super Contra is primary. If you have more than one matching component, please use Super Contra game. I'll organize imports or Spring Framework context annotation primary is imported in, and I would save this in here. I would stop and start the application again. Do you think the application will start up fine now? What would be printed in the console? Up, down, left, and right. Where is this defined? You can see that this is defined in the Super Contra game. To make it very clear, I'll just put Super Contra up in here. So that's very clear, it's coming from the Super Contra game. So if you have multiple matching beans and you want Spring Framework to choose one of them, you want Spring Framework to give high priority to something, what you can do is to make it primary. Now, what I would recommend you to do is to take a pause and do this as an exercise. Create a sample implementation for Pacman and make Pacman the primary bean. I hope you got a chance to do that. The exercise should have been pretty simple. So I can go in to Super Contra game, copy this, and I can call this Pacman game and say, okay, open up the Pacman game. And over here, you can see that Pacman game already has a primary annotation. I'll just change small thing in the implementation. I'll call this Pacman game up, and I'll go to the Super Contra game and remove the primary annotation. I'll comment this out and organize imports in here. So what we did is now we made the Pacman game as the primary bean. So if there are multiple implementations of gaming console, we are telling Spring Framework to use the Pacman game. Let's stop this and start the application again. What would happen? You can see that the Pacman game is used. So we use the add primary to indicate that something is primary, and we created a dummy implementation for Pacman and we made it the primary as well. Now that we played around with the Spring Framework a little bit, let's see how to solve a few problems with it. Let's go to the Game Runner and remove add component in here. What would happen? What do you think will happen? Let's stop and start the application up. What do you think will happen now? Error. What is the error? It says no qualifying bean of type Game Runner is available. So if I click this and go to that line, it's saying no qualified bean of type Game Runner is available. Whenever you see such kind of an error, whenever you see an error saying no qualified bean of type is found, there might be a few errors that you are doing. The first error is obvious. You might have missed the add component. That's what we have in here. So you can enable add component and it would work. But there are other possibilities for errors as well. One of the other possibilities is that you are creating the component in a package which is not scanned by the Spring Framework. Let's say I move this Game Runner class to a different package. So let's say package game dot instead of com in 28 minutes learn Spring Framework, let's say I'm using com in 28 minutes dummy. We'll remove this package a little later, so the name does not really matter. So if I do a control 1 and move Game Runner to that particular package, you'll see that there's a package created. Let's do organize imports at the source name Java level. And you'll see that most of the imports should be automatically organized. And now, if I stop the application and start it again, you'll see that again there is an error. Same error happens again. No qualifying bean of the type com in 20 minutes dummy is available. Why? Because by default, the component scan is only done on com in 28 minutes learn Spring Framework. Only this specific package where you have the Spring Boot application defined is component scanned. Other packages are not component scanned. If you want, you can add other packages. So I can say component scan. I want to component scan both the Spring Framework package and I want to component scan the or Spring Framework or in 28 minutes dummy as well. Let's do an organize inputs. So we are saying I want to do a component scan of 2 packages. Package 1 is this, package 2 is this. So this package and this package, this package and this packages. Let's see what will happen if I stop and start the application. This time everything goes fine. So it's very important to remember what is under component scan. Spring is not able to find a component. Number 1, check if you have a component. Number 2, check if the component is part of component scan. Now, I don't really want to leave this code in here. What I would do is I would go back to default component scan. I'll comment this component scan out and let's go back to switching Game Runner to where it should be. So it should be in the game package. I'll drag and drop it and I would say update references and say okay. And I can go and delete this one as well. So I'll delete the dummy package. So we are back to the state we were earlier. So if you stop and start the application now, you should not have any problems because our game runner class is now in the com in 28 minutes learn Spring Framework sub-package, which is game. So you should see that we are able to launch the application up. Fine. Typically, a lot of beginners don't know what needs to be done when you have a problem when you're using Spring Framework. The idea behind this step was to quickly show you what you can do. Number one, you can enable debug mode. Number two, you can see if there is a component. Number three, you can check if something is not part of a component scan. I'll see you in the next step. Welcome back. In this step, let's shift our attention to question 5. How is Spring Jar downloaded? The answer to that is Maven. Think about this. What would happen if you manually download Spring Jar? Let's say I would want to make use of Spring Framework. I would manually download it. Is downloading Spring Framework alone sufficient? The answer is no, because Spring Framework also needs other jars. Spring might need a logging jar and other jars along with it. So what you need to do is to go and download all the other jars as well. So you need to download Spring jars and the dependencies of Spring jar and also the dependencies of those jars. So you would not need to download one jar, but you might need to download 10 or 15 or 20 jars. And imagine what would happen if you have to upgrade to a new version of Spring Framework. Then you need to go through the entire cycle again. And that's the problem which Maven tries to avoid. Maven tries to make it very, very easy to manage the application dependencies. Remember that application dependencies are very, very different from Spring dependencies. To run our application, we would need Spring Jar. So that's an application dependency. Spring Jar is an application dependency. And to download Spring Jar, we would use Maven. Inside a Spring application context, there might be a number of beans which are created. And these beans might need other beans. Those are what are called Spring dependencies. What we are talking about in here are application dependencies. Basically, whatever things that you would configure typically in a pom.xml. Over here in the pom.xml, what we are configuring is 3 different application dependencies. Once you configure those dependencies in your pom.xml, Maven would automatically download the specific dependency and the dependencies of the dependency. And that's the reason why when you just add in a couple of simple things like this, we just have 3 definitions in here. And if you go to Maven dependencies, you would see that there are a lot of jars which are present in here. So if you select all of them, you would see that there are more than, let's select all of them quickly. How many are there in here? Right now, I have about 60. This will change with time. So there might be lesser number of jars or more number of jars. With different versions of Spring Framework, this keeps changing. But you can see that there are about 60 jars which are downloaded for me just by defining these 3 things in here. All this is done by Maven. Maven automatically downloads this. And when I'm running the application is configured to use these jars directly. So if you add a dependency on Spring Framework, Maven would download Spring Framework and the dependencies of Spring Framework as well. And all this configuration is done in pom.xml. You'd see that in pom.xml, each artifact is identified by a group ID and an artifact ID. Group ID is like the package name, artifact ID is like the class name. Now you might be wondering, how is the Spring Framework coming in here? We added a dependency on Spring Boot Starter. How is the Spring Framework coming in here? Spring Framework comes in because Spring Framework is a dependency of this dependency. So Spring Framework is defined in Spring Boot Starter. So if you control click or command click and say open pom.xml for this, you can go to the pom.xml of Spring Boot Starter. And you would see that the Spring Framework is defined in here. So you can see that Spring Core org.spring framework, Spring Core is what is present in here. So the important features of Maven are, number one, it defines a simple project setup. So if you look at this project, there is a simple setup which is used. So if you look at source main Java, this is where all the Java code, all the source code that we are writing right now is in. If you look at source main properties, this is where the application configuration is present. Application.properties. You can configure properties for your application. There is another folder called source test Java. This is where you can write your unit tests. And there is a pom.xml which is present in here. This is where you define your dependencies. Typically, any new Java project you go to, it would be using the exact same structure. This structure is the default structure in all Maven projects. So it defines a simple project setup that follows best practices. The great thing is that it enables consistent usage across all projects. Let's say you are working in one project and you move to another project. You want to find out where the source code is, where the tests are written, where the application properties are. You don't need to worry about it. If they are using the same Maven standards, you know where the source code would be. You know where the application configuration would be. You know where your test code would be. So this enables standardization across multiple projects. It enables consistent usage. And the other important feature is it manages dependency updates and transitive dependencies. You can manage your dependencies, and you can also manage the transitive dependencies of the dependencies. What is a transitive dependency? We saw that in pom.xml, we have this defined. So this is the dependency. However, this has other dependencies. So the Spring framework is a dependency of this one. And when we click open pom.xml for this, you can see that we can see the dependencies of Spring Boot Starter. So I add a dependency into the project. That dependency might have other dependencies. These dependencies are called transitive dependencies. So dependencies of dependencies are what are transitive dependencies. So Maven not only downloads the dependencies, but also downloads the transitive dependencies. Now, to just help you identify the power of Maven, let's remove this Spring Boot Starter web from here. So I'm just removing this dependency and saving this. You can see that there is a compilation error because in the web controller, there is an annotation which we are using, REST controller. Where is this annotation defined? This is defined in a component called Spring Web MVC. And that component is provided by Spring Boot Starter Web. Since we deleted it, that jar is no longer available. And that's the reason why there is a compilation error. Another thing you'd see is the number of Maven dependencies also would have reduced. Once I removed Spring Boot Starter Web, and if you go down here and see how many dependencies are present in here, you can see that there are only 46 right now. You might see a different number, but this number would be lesser than what you would have when you have Spring Boot Starter Web in here. So if I add back Spring Boot Starter Web and go and check, you can see that there are a lot of new ones which are coming in. And in total, there would be more than 50 dependencies which would be present. In this step, we got a 10,000 feet overview of Maven. Maven makes it easy to manage your application dependencies. I'll see you in the next step. Welcome back. In this step, let's look at dependency injection types. What are the different types of dependency injections which are offered by Spring Framework? They're construction-based dependency injection, setter-based dependency injection, and field-based dependency injection. Now, what is the difference between these different types of injections? Until now, one of the dependency injection types that we made use of is constructor-based. This is where we are defining at autowired. So we are saying use at autowired, and we saw that when we provide a constructor, the constructor is used to do the auto wiring. So if you go in here and you search for using constructor, you'd see that there is using constructor. So what we are making use of in here is constructor auto wiring. However, let's do a small thing. Let's comment this and now let's create a setter method. You can do a right click, source, generate getters and setters, and let's choose only to generate a setter. So I'll do a generate set game. So this would create a set game method for us. So this is a setter which is created for us. So you can see it's very, very simple. Void set game, gaming console game, this dot game is equal to game. It's very, very important that the name game in here matches the game in here. So set game, gaming console game, this dot game is equal to game. And I'll say system.out.println using setter. What we'll also do is to move the auto-add from the instance to the setter. So I'll move the auto-add annotation to the setter. One other thing I would change is application.properties. I don't want to have debug mode. There is a lot of log which is coming in. I don't want all the log. So I'll stop the debug log and stop and start the application again. What would happen? What is printed? You can see that right now we are using setter injection. So we are actually wiring in the dependency using setter. And the other option is not to use setter or constructor injection, but to use something called field injection. So over here, we don't need to even create a setter or a constructor. All that you need to do is to directly go to the field, define an auto-add and save it and stop and start the application. You would see that nothing is printed in here because this is now making use of the field level injection. The injection in this case happens through reflection. Now, you might be thinking there are three important types of dependency injection. Which one should you make use of? The one which is always recommended by Spring is constructor injection. So provide a constructor which has all the dependencies as arguments. So if I have 5 dependencies in here, I can provide a constructor with 5 dependencies as arguments, and then this would be automatically used by Spring to create the object for game runner. This is the one which is recommended by Spring because all the dependencies are set right at the time the object is created. So at one go, Spring can create the object with all its dependencies. If you use setter injection, what Spring needs to do is first it needs to create the game runner class, and then it needs to call setter methods on each of the dependencies. So it would create the game runner class. It would then say set game and do the set. And then again, it needs to call set on the other dependencies as well. And that's the reason why the Spring team recommends constructor-based injection. In constructor-based injection, dependencies are automatically set right at the time of the creation of the object using a constructor. In this step, we looked at the different types of dependency injection. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In the last few steps, we played around with one of the core features of Spring Framework, which is dependency injection. How do you define a component scan? How do you identify a component class? How do you identify a dependency? That is the core feature of the Spring Framework. However, in addition to the core features of the Spring Framework, Spring also offers a lot of other features. If you want to write a unit test, or if you want to develop a web application, Spring provides modules for that. So the Spring Framework is divided into a number of modules. The core is the IOC container, application context, at auto-wired, at component. All these are part of the core. That's the basic dependency injection functionality. In addition to this, there are other modules. If you want to write unit tests, you can use testing module. If you want to talk to a database, typically whenever you have an application, you might want to talk to a database. And if you look at typical frameworks which are used to talk to a database, you might be talking about JDBC or Spring JDBC or Hibernate. So Spring allows you to connect to all those frameworks. You might want to build a web application. We built a simple flow a little earlier. So if you have something like that, Spring also provides you with modules for that. One of the emerging trends in the last few years is to build reactive applications. And one of the popular frameworks that is provided by Spring to build reactive applications is Spring Web Flux. Spring Web Flux is one of the modules that is provided by Spring. Similarly, if you want to integrate with other applications, Spring also offers a number of modules to be able to do that. As you can see in here, the core feature of Spring is dependency injection. However, there are a lot of modules that Spring provides to help you build applications. You cannot build application just by using dependency injection. You need to be able to talk to a database. You need to talk to an external system. You need to be able to write unit tests. You need to get data from the database. And to do all these things, Spring provides a number of different modules. Each application can choose the modules that they want to make use of. Not all projects might need to talk to other systems. So they might not need anything for integration. So as a person who's designing their application, they can choose which Spring modules you'd want to make use of. You don't really need to make use of everything that comes built into the Spring framework. In this step, we talked about the modularization of Spring framework. This is one of the reasons why Spring framework is very, very popular. You don't need to use everything that Spring framework provides to you. You can pick and choose the specific things that you would want to make use of. I'll see you in the next step. Welcome back. In this step, let's talk about Spring projects. What are Spring projects? If you look at the last couple of decades, there has been a lot of evolution in how we develop applications. Earlier, we used to have web applications. Now we have REST API, microservices. We are deploying to the cloud, AWS, Azure, Google Cloud. So the architectures of applications that we build are changing. They are not the same. How I built the applications a few years back is not the same as how we would build applications a few years down the line. And that's where Spring projects come into picture. Spring needs to keep evolving with the trends which are happening in the technology world. And there are a number of Spring projects which help you keep up with the evolution. One of the most important evolutions in the last few years is microservices. I have worked in applications which have thousands of classes. Some of the applications that I have worked on have more than 100,000 classes. These are large applications. These are called monoliths. Instead of building monolithic applications, the modern trend is to build smaller applications called microservices. And to build microservices, one of the most popular frameworks today is Spring Boot. So as soon as there was evolution towards microservices, there was a new Spring project called Spring Boot, which was introduced to help us build microservices. Another important trend from the last few years is the evolution of the cloud. Today, we would want to be able to deploy our applications to AWS, Azure, Google Cloud, and other cloud platforms. You'd want to build cloud native applications. And that's the goal of Spring Cloud. Spring Cloud is a Spring project which helps you to build cloud native applications. A few years back, the only type of databases that were present are relational databases. Relational databases are databases where you define tables and you write SQLs to query the data from your tables. However, in the last decade, there are a number of NoSQL databases which became popular. Spring Data helps you to talk to different types of databases, whether it's NoSQL or relational databases, the same way. So you can integrate with different types of databases. Your applications need to talk to other applications. Spring Integration is a Spring project which helps you to talk with other applications. Security is a very, very important part of building applications. Whether you're building a web application or you'd want to build a REST API or you'd want to build a microservice, all of these need to have really good authentication and authorization. Spring Security is a Spring project which will help you to build authentication and authorization into your applications. So as you can see in here, as the needs of your applications evolve, Spring is coming up with new projects that helps you to keep evolving with the technology trends. It's more than 15 years since the first time I made use of this Spring framework. And during all these years, Spring framework remains the number one choice for building applications using Java. The most important reason for that is Spring modules and Spring projects. In the last couple of steps, you would have seen a lot of new terminology. Do not worry if you do not understand that terminology. As you go further in your career, you would understand most of that. The important objective behind talking about Spring modules and Spring projects is to help you understand that the ecosystem of Spring is much larger than just the dependency injection feature. We will explore some of these Spring modules and Spring projects as we go further in the course. I'm sure you're having an interesting time, and I'll see you in the next step. Welcome back. I'm sure this journey in this specific section has been a roller coaster guide. There are a lot of new terminology that we have introduced to you, and we hope we were successful in giving a 10,000 feet overview of the Spring Framework. Spring Framework is so vast that covering all the features related to Spring Framework would take more than a few hours. The idea was to give you a big picture overview of the Spring Framework. The idea was to help you understand the important terminology which is associated with Spring Framework. Dependency injection, auto wiring, Spring Beans, component scan, IOC container. And we also understood the concept of Spring modules and Spring projects. As we go further in the course, we'll play with other Spring modules and projects. As we understood in this specific section, the advantage of Spring Framework is that you can write loosely coupled code focusing on your business logic. It provides you with architectural flexibility because you can pick and choose which Spring module to use. And Spring Framework is evolving with time, so your application can stay in touch with the evolving trends. I'm sure you had a wonderful time in this section, and I'll see you in